we have here next, guys, is the probability of getting six different numbers on a die are shown in the table below. Probability of getting a 1 is 25%. Probability of getting a 2 is 25%. Probability of 3 is getting 15%. Dennis, wake up. Probability of 4, 15%. 5 is 10%. 6 is 10%. Now, guys, the way to do this is what's called the expected value. Expected value, also known as E of X. What you do is you multiply each of these together and then you add them. So 1 times 0.25 is 0.25. 2 times 0.25, 0.5. 3 times 0.15, 0.45. 4 times 0.15, 0.6. 5 times 0.1, 0.5. And finally, last one, 0.6. Add them all together, you get 2.9. You're expected on average to get an average score of 2.9 for this game. Stop with the noise back there, just hearing it way too loudly. Okay. There's a game at a fun fair. It costs €3 to play the game. The player rolls the dice once and wins the number of euros shown on the die. The sentence below describes the difference between using the above biased dice and using a fair unbiased dice to play this game. Okay, guys, if you play this game many times with a fair dice, you will win an average of, we don't know. So let's put this clear. If you play with a fair dice, you should get 1 in 6 should be the amount of times you should get it 1 in 6 times, shouldn't you? Every single time you throw the dice, you have a 1 in 6 chance of getting that number correct. Let's get the expected value when it's a fair dice. So you multiply 1 by 1/6 and you get 1/6. Multiply 2 by 1/6, 2/6. Multiply 3 by 1/6, 3/6. And then 4/6, and then 5/6, followed by 6/6. Okay, add them all up together and divide by 6. 3 plus 3 is 6, plus 4 is 10, 21 over 6. What is 21 over 6? €3.50. When you play this game with a fair dice, on average you're expecting, you win €3.50, don't you, on average? How much do you pay to play the game though? €3. So you win €3.50, but you pay €3. That means how much are you going to get paid to play? You're going to get 50 cents. And then finally, if you play with the biased dice, which is this one here, it's €2.90 minus €3. So we're going to lose 10 cents every time. Okay. An unbiased circular spinner has a movable pointer and 5 equal colours. Okay, so basically you're talking about just spinning it around here until it lands on something. Okay. Now, find the probability that the spinner stops on green for 1 spin. How many greens is there? So just 2 and 5. Quite easy. List all possible outcomes. Okay. All possible outcomes of 3 successive spins. Red, red, red. Red, red, green. Now get the green and start shifting it over. Red, green, red. Shift the green over again. Green, red, red. Start off with the same way with greens. Green, green, green. Green, green, red. Shift to red. Green, red, green. And then shift it again. And you get red, green, green. Now there's another way of doing this. We have 3 different we play it 3 times. How many outcomes do you have in the first one?
4.
No. We either get red or green. 2. We either get red or green a second time. And we either get red or green a third time. 2 multiplied by 2 multiplied by 2. 8. I have 8 different outcomes. Do I have a total of 8 different outcomes here? Yes, we do. That's you done. Okay. So lads,